In the last few lectures, we have discussed the solution of the system of linear equations using Cramer's rule. And the Cramer's rule is considered as the biggest tool to find out the solutions of the system of simultaneous linear equations. So what we did in the last few sessions, actually all the examples which we have discussed, they are of the same nature. So before proceeding this example, we know that a system of simultaneous linear equation can be classified in two categories, that is Ax is equals to B and then Ax is equals to C. If the system of simultaneous linear equation can be written as Ax is equals to B, then we call it as non-homogeneous system of simultaneous linear equations, right? And if the value of the B, the terms at the right hand side are identically 0, then the system converts to Ax is equals to 0. Then this is called as homogeneous system of simultaneous linear equations. And all the questions which we have solved in the last few lectures, they are almost of non-homogeneous nature. Right? So in this lecture, I will try to solve you one or two examples which are of homogeneous nature, and we will observe how we can find out the solution of a system of homogeneous simultaneous linear equations using Cramer's rule. So before finding out the solution of this question, let me recall the condition or existence for the condition of consistency. Under what condition the system Ax is equals to B and Ax is equals to 0 are consistent or inconsistent. We know that the system Ax is equals to 0, that is a homogeneous system, if determinant of A is not equals to 0. This implies the system has trivial solutions, right? Trivial solution, I have discussed the term many times. Trivial solutions means the values of the variables involved in the given equations are identically 0. Such a solution is known as trivial solution. Condition 2 is what? If determinant of A is identically 0, this implies the system has infinite many solutions, right? So these are two conditions which we can use to find out the solution of a system of homogeneous simultaneous linear equations, right? So from these two conditions, actually, if you look at these two conditions, what we observe, whenever a system is homogeneous, then it is always consistent. Consistent means it will always have solution, because under these two conditions, condition 1 gives you a trivial solution and condition 2 gives you infinite many solutions. So any system which is homogeneous, it is always considered as a consistent system. On the other hand, we know that a non-homogeneous system of linear equations, Ax is equals to B, it may be consistent or it may be inconsistent, right? Inconsistent means it is not having any solution. So in view of these conditions for the homogeneous system, we will solve the given example. See, solve the following system of equations using Cramer's rule. So we have given the three equations in three variables x, y, and z. Right? Solution of this system means determine the values of x, y, and z which simultaneously satisfies all the three equations, right? So We know that the given system of equations can be written as Ax is equals to B. This is the matrix notation of any system of linear equations. Here B is what? B is the entries at the right hand side of the given equation, and the entries of the right hand side of the given equation are identically 0. Therefore, our system is homogeneous, right? Ax is equals to 0. Clear? The first thing is what? Before starting the solution of any system of linear equations, first examine whether the given system of equations is homogeneous or non-homogeneous. So this system is homogeneous because all the terms at the right hand side of the given equations are identically 0, right? So the given system of equations can be written as Ax is equals to B. We know that B is identically 0. What is A? A is the matrix of the coefficient of the variables x, y, and z. Capital X simply represents the variables involved in the given equation. So there are three variables x, y, and z. So x should be taken as x, y, z. A is what? A simply denotes the matrix of the coefficients of the variables x, y, z. And I have determined this matrix many times in many examples. So I hope you understand how to write down this matrix. But for your satisfaction, let me explain how we can write down this matrix once again. A simply denotes the matrix of the coefficients of the variables x, y, z, right? Take equation 1. In equation 1, the coefficient of x is 1, coefficient of y is 1, coefficient of z is minus 6. So 1, 1, minus 6 is the first row of the matrix A, right? Which we can obtain from first equation. Now take equation 2, right? The coefficient of x here is 3, the coefficient of y is minus 1, and coefficient of z is minus 2. So 3 minus 1 minus 2 is the second row of the matrix A, which we can obtain from equation 2, right? Now take the last equation. Here the coefficient of x is 1, coefficient of y is minus 1, and coefficient of z is 2. So 1, minus 1, and 2, which is the third row of the matrix A, which we can obtain from equation 3. So this is how we can determine, or we can write down, the matrix of the coefficients of the variables, right? So we have represented the given system of three simultaneous linear equations to the matrix equation, right? Now the next step is what? Naturally, this is a homogeneous system of equations, so it will be consistent, right? It will have some solutions. And what kind of solution it will have, we can determine from these two conditions. Either its determinant is non-zero or its determinant is 0. So for this, we will calculate the determinant of the matrix A, right? Since determinant of the matrix A is this, right? Simplify this determinant, and the value of this determinant is coming out to be 0. So we are getting condition 2. See this. How we can find out the value of this determinant? I have explained a number of examples for expansion of the determinant. I hope you can find out the value of this determinant yourself. But for your convenience, let me explain once quickly. What we will do, we can expand this determinant along any one of the three rows or any one of the three columns. I am expanding this determinant along the first row. See, the first element of the first row is 1. What is the rule? Delete the row and column in which 1 lies. So this row and this column is deleted. What is left? Minus 1 into 2 minus 2 minus 2 into minus 1, 2 minus 2 minus 2 this. Now second is what? Minus 1. This is minus 1. Delete the row and column in which this 1 lies. What is left? 3 into 2, that is 6, minus 2 into 1, that is minus 2, minus plus, this is your second term. And third term is what? Minus 6. Delete the row and column in which minus 6 lies. So what is left? 3 into minus 1, that is minus 3, minus 1 into 1, minus plus, so we will get here minus 1, right? Simplify this, what you will get? Minus 12 plus 12, that is 0. So the determinant of the matrix is identically 0. So by condition 2, that is this one, what we get, the system of equation will have infinite many solutions, right? Since determinant of A is equals to 0, thus the system is consistent and it will have infinite many solutions. Clear? And we have solved many questions based on infinite many solutions, right? You can determine the infinite many solutions means I have told you what is the meaning of infinite many solutions. Infinite many solutions simply refers to values of the variables x, y and z. They will be in terms of any constant quantity. If we are taking the values of the variables in terms of any constant quantity, so by changing the value of the constant, the solution will also change. That is why we say that the system is having infinite many solutions. So see here, the process is what? If we take x is equals to c, right? We are having three equations. If we take x is equals to c and solving equation 1 and equation 2, see what will happen. See, put x is equals to c in equation 1 and x is equals to c in equation 2 and then solve these two equations. See, x is equals to c means c plus y minus 6z, this is equals to 0, this is equation 1, and equation 2 will be what? 2c minus y minus 2z, this is equals to 0. Adding these two equations, if you will add up these two, what you will get? See here, c plus y minus 6z plus 2c minus y minus 2z is equals to 0. So what you will get, see here, this y and y will be cancels out. 2c plus c, that is 3c. 6z minus 2z, that is, sorry, 3c. This is 3c, not 2c. So 3c plus c, that is 4c, right? 4c and 6 minus 2, that is 8z. This is equals to 0. So c will be equals to 2 times of z, right? And what is the value of z? From here, this implies z is equals to c by 2. Clear? So z is coming out to be c by 2. So what we did, we have taken out of the three variables. The approach is what? Out of the three variables, take any variable as a constant. Here we have taken x is equals to c. So put x is equals to c in equation 1, you will get this equation. X is equals to c in equation number 2, you will get this equation. So these are the two new equations, right? Now add up these two equations. By adding up these two equations, we are getting the value of z is coming out to be c by 2. Clear? So one variable we have obtained, the value of z is c by 2 and the value of x is c. What is left? Y is left. Now you can find out the value of y. A number of ways are available to find out the values of y. What did it here? Adding second and third equation again to get the value of y as c. See, what is equation number 2? This is what? 3c minus y minus 2. What is the value of z? Z is equals to c by 2. So into c by 2, this is equals to 0. You will get here 3c minus y minus, this will cancel out, c is equals to 0. This is your equation number 2. Now what is equation number 3? C minus y plus 2 into z is what? C by 2. So 2 and 2 will be cancels out. What is left? C minus y plus c, this is equals to 0. Solve these two equations, you will get the value of y as is equals to 2c. This you will get as the value of y, right? Solving this and this, these two equations, right? Or, you know, you can also find out this value like this in a simple way. See, x is what? X is coming out to be c. This is c. Z is coming out to be c by 2, right? X is here, Z is here. Determine the value of y. Put the values of x and z in equation number 1. See, what is equation number 1? C plus y minus 6 into z is what? Z is c by 2. This is equals to 0. So what you will get here? C plus y minus 2, 3 the 6, that is 3c. This is equals to 0. Y minus 2c is equals to 0. So y is equals to 2c, right? So y is 2c, x is what? What is x? X is c. We have taken this x as c. This is the value of x. X is c, y is 2c, and z is c by 2. Hence the solution is what? X is c, y is 2c, and z is equals to c by 2. This is the solution of the system given here. C being a constant, we can change the values of C. As we will change the values of C, the solution of the system will also change. So C being a constant can have infinite many values. Therefore, the system is also having infinite many solutions. So this is how we can solve a system of homogeneous equations using the Cramer's rule. Let us have one more example. Solve the following equations by Cramer's rule. See, this is 3x square plus 4y square is equals to 91. 6x square minus y square is equals to 38. Look at these two equations very carefully. What is the difference between this example and all those examples which we have already discussed? Here, we are having two variables x and y, right? But the power of or the degree of the variables x and y is 2. X 2 and y is 2. So this is not a linear equation, because for a linear equation, the degree or the power of the variable should be 1. Clear? So this is a non-linear equations. So how we can find out its solution using Cramer's rule? And you know, Cramer's rule is given only for finding out the solutions of the linear equations. Right? So see what we will do here. This is our system of two equations. So what we did here, if we take a is equals to x square and b is equals to say y square. Clear? X square is equals to a and y square is equals to b. Then these two equations will be transformed as, see, 3a plus 4b, this is 91, 6a minus b, this is equals to 38, right? Now look at these two equations here. A and b are considered as two variables and the degree or the power of a and b is 1. Therefore, these two equations are linear. So what we did? By using this substitution, we have transformed a non-linear system of equations to a linear system of equations, and once a system has been transformed to a linear equations, we can very easily use the Cramer's rule to find out its solution. So look at these two equations. These are the two equations which we obtained after using the substitution a is equals to x square and b is equals to y square. Here a and b are considered as a variable, not the constant. So solution of these two equations means find out the values of A and B which simultaneously satisfies both of these two equations. And of course, this system is what? This is a non-homogeneous system of equations, right? Sorry. Because Ax is equals to B. Now you can proceed, you know the method to find out its solution. The above system of equations can be written in matrix form like this. Ax is equals to B. You know, as usual, the matrix of the coefficients of the variables A and B. Be careful. Here the A and B are the variables. X is the matrix of the coefficients of the variables involved, and B is the quantities at the right hand side. So this is our A, this is X, and this is B. Now proceed, find out the determinant of the matrix A. So determinant of A is coming out to be minus 27. It is not equals to 0. And we know that when the determinant of a non-homogeneous system of equations is not equals to 0, then the system has a unique solution. This is D. Now find out dx and dy, right? Dx, dy, how we can obtain dx, dy, we all know that. Dx is obtained by replacing first column of the determinant D by the entries at the right hand side, right? This is the first column, 3, 6. This 3, 6 should be replaced by 91 and 38 to get dx in dy. The second column should be replaced by 91 and 38, we will get dy. The value of dx is coming out to be minus 243 and the value of dy is coming out to be minus 432. Simplify these two values, dx and dy. And finally, A is equals to dx divided by d and B is equals to dy divided by d. So A is coming out to be 9 and B is coming out to be 16, right? We have determined the values of A and B. And what substitution we have used, because the original equations are in terms of x and y, they are not in terms of A and B. So we will have to determine the values of x and y. So A is equals to 9. It means what we have taken A we have taken as x square is equals to 9, and B we have taken y square is equals to 16. So from here what we get, x is 3, and from here what we get, y is 4, right? So x is 3 and y is equals to 4 is considered as the solution of the given system of equations, although you have seen that this system of equations is not linear. So students, I think this is all about the Cramer's rule, how we can use the Cramer's rule to find out the solution of a non-homogeneous system of equations as well as a homogeneous system of equations. So thank you very much for your patience, love. Thank you.